Good afternoon. I am Jeon, a technical leader at SK Hynix. Before I begin my presentation, I'd like to briefly introduce myself. I joined SK Hynix in 2011, initially focusing on PDK development and layout automation. Since then, I've been working on developing in-house tools and improving workflows in the areas of static ERC, circuit optimization, and circuit modeling. I will talk about case where we have improved the design environment through the development of in-house tools utilizing OpenAccess API along with related proposals. My presentation today topic is design environment enhancement using OpenAccess API. Here's the agenda. First, I will explain the history of OpenAccess API implementation and at SK Hynix. Second, I will discuss case studies and proposals involving the application of OpenAccess API. Lastly, I will provide a summary. The size of memory design is continuously increasing over time. While the size of chips is decreasing, the number of transistors is increasing exponentially. In particular, with the emergence of the stacked product HBAM product lineup, the design size has grown even larger. The graph 1 shows the runtime trend of an in-house tool for static ERC according to the density of DRAM. When the design was at the 8 gigabit level, the runtime was less than 1 hour. However, as the density increased, the runtime gradually increased, reaching almost a full day for the HBM product lineup, which began to affect design work time. Although several methods were tried to read increasing runtime of in-house tools, there were limitations in reducing it, leading to the development of in-house tools using OpenAccess API. At the time SK Hynix first implemented OpenAccess API, it was limited to basic design automation tools in batch mode. However, the scope gradually expanded to include design optimization and design verification and design modeling. This expansion was supported by efforts to enhance the functionality needed, thereby increasing the efficiency of using OpenAccess API and maximizing its performance. These efforts include the development of a high-level functional library and a multi-processing environment, which will be explained in the sections to below. The proprietary language lacked support for multi-threading and multi-processing, which presented challenges in reducing the runtime for our in-house tools. Additionally, splitting block to run with in-house tools resulted in higher license consumption. To address these issues and optimize runtime reduction, we transitioned to using OpenAccess API and developed a multi-processing environment. Here's an overview. The master process assigns cells to sub-processes, which are then executed in parallel. By applying this approach to hierarchical copy, we achieve roughly a 45% decrease in runtime using for sub-process. The reason that the runtime does not become 1 per n with the number of processes is that the master process must build the hierarchy and distribute the cells. SK Hynix developed in-house tools by switching to OpenAccess API and applied multiprocessing as described in the previous section to reduce runtime. The following graph shows the case where in-house tools were transitioned to OpenAccess API to achieve reduced runtime. Graph 2 is a design automation in-house tool that exports information of specific net within a full chip, and it only reads the design and creates a file. The runtime measurement conducted on 5 target projects showed an average runtime reduction of 95.3%. And Graph 3 is an in-house tool, generates modeling information of resistance and capacitance for certain nets in a full chip design. It reads and writes designs. We measured the runtime across 6 projects and found an average reduction of 76.8%. Besides the two cases mentioned above, even though we couldn't measure exactly, a lot of our in-house tools have seen a big reduction in runtime by using OpenAccess API. We have now made it possible to integrate our in-house tools using OpenAccess API. Our in-house tools, which were originally developed in C++, couldn't directly access the design database. So we always had to learn the physical design tool and handle everything using proprietary EDA language. You can see the workflow. There was a point where we needed to access the design database. At that stage, the user had to manually extract data from the design database using proprietary EDA language and then feed it back into the C++ based in-house tools. However, after adapting OpenAccess API, we have been able to develop in-house tools that can handle input and generate result data without any user intervention. This has improved performance and allowed us to use our EDA software licenses more efficiently. With the adoption of OpenAccess API, we can now access the design database directly. However, when it comes to generating standard EDA data like NetList, GDS, and OASIS, we still have to go through EDA software. This means a user has to jump in to create this standard data, which disrupts the workflow continuity. So, if OpenAccess API could include functionality to generate standard EDA data, it would greatly improve tool integration and work efficiency. Here's the story related to high-level functions. OpenAccess API primarily consists of functions with individual capability. So when implementing functions at the level of proprietary EDA languages, multiple OpenAccess API functions are combined. In this process, you need to handle exceptions for each function, and code execution is often interrupted due to human error. Therefore, SK Hynix has developed frequently used function combinations as high-level functions with built-in exception handling. These high-level functions are developed in the form of .so libraries and are being utilized in the development of in-house tools. The following is an instance creation developed as a high-level function. When implemented using the basic functions of OpenAccess API, the process consists of 3 steps: instance creation, properties creation, and instance pins creation. Properties creation, however, SK Hynix high-level function generates an in-house instance in a single step using the provided properties and instance pins information with exceptions being internally handled. OpenAccess API provides sufficient functions to handle the design database, but as explained in the previous chapter, many of them consist of individual functions. Although SK Hynix has developed and operates a high-level function library, there are still some shortcomings in terms of optimization, such as performance and exception handling. Therefore, we hope to see more high-level functions added comparable to those found in proprietary EDA languages. The flowchart below is an example of a high-level function routine that obtain a switch view from an instance. To get switch view from an instance, you need to first obtain the master information of instance and search for the imp view name list from all views of the master cells in three-step processes. A function that reduces these three steps into a single step exists like proprietary EDA language level. We hope that more combined functions are added to OpenAccess API. Here are my final suggestions. The most challenging aspects of developing with OpenAccess API was finding examples or specific function references. It is very difficult to find information online, and looking through the HTML files that describe the classes within OpenAccess API is almost the only way to access this information. Consequently, a lot of trial and error is required during development. For example, when I was using OpenAccess API to build a small car, I laboriously implemented function 1, function 2, and function 3 to create the car on the left. However, afterward, I happened to discover a sports car already included by default in OpenAccess API. Instances like this demonstrate how a lack of information can lead to laboriously implementing something without knowing that a better feature already exists. Therefore, it would be great to have a channel or platform where OpenAccess API developers can discuss or engage in Q&A similar to Stack Overflow. If developers can effectively find the features that they want, it could reduce inefficient trial and error. Here is the summary of today's presentation. SK Hynix has been improving its design environment by utilizing OpenAccess API. By converting existing in-house tools to OpenAccess API and developing a multiprocessing environment, we achieved a reduction in runtime by over 50%, 70%, and direct access to the design database has enabled integration between in-house tools. Furthermore, we have developed and are using a high-level function library in order to enhance the usability of OpenAccess API. While OpenAccess API is already an excellent tool, we propose three aspects for improvement in terms of development efficiency. The number one, exporting standard EDA data. Number two, support more high-level functions. Number three, open user group proposal. Finally, the achievements presented today are not the result of my efforts alone. They are all the outcome of collaborating among many developers at SK Hynix, and I was given the honor of presenting on their behalf. This concludes today's presentation. I would like to express my gratitude to everyone for listening. Thank you.